Hello everyone, welcome once again. Now we have a nice cubic equation over here. We have x cubed minus 3s being equal to 2, and then we have to find the possible values of x. Now I'm going to use a very simple method in solving this. Unlike you having a quadratic equation, very easy to solve, a linear equation, very easy to solve. But then when it comes to cubic equation, they are kind of complicated. But then I'm going to show you a simple way to solve this. Now, first let's look at the cubic formula. So from the cubic formula, if you have, let's say, a plus b cube. Now a plus b cube, I have a very simple identity that I use, which is just a cube plus b cube plus 3ab here into brackets a plus b. That is when you expand a plus b 3 times. So when you expand it 3 times, and then you multiply through, you are basically going to get something of this sort. Now what I'm going to do is that I'm going to set because we have a plus b here, a plus b here. Now let's set this to a certain variable, and we are going to call that variable, let's say s. That before we set a variable, let's try and then make, because we have a cube b cube over here, let's try and then make a cube plus b cube the subject. Now when we make a cube plus b cube the subject, now it becomes so we are basically going to have this to be a plus b here cube, and then this goes to the other side, it becomes minus a plus b in this case. Now this is what we are going to get. Now we are still going to say, let's say x here equals a plus b, right? Now if s equal to a plus b, which means that this equation now becomes, now I'm setting s to a plus b because we have a plus b here, a plus b here, unlike we have just a b, which is only one of it, but then we have two of it. So I'm just factorizing this into that to make the equation very simpler. So it becomes s cube minus so this becomes 3ab, then multiplied by the x in this case. So this is what we are going to have. Now if we compare this equation to the general equation here, if we compare this equation to the general equation here, now you realize that we have this s cube minus 3s being equal to 2, right? Now compare this to that of this here, and then compare this to that over there. Now this we have the s cube minus 3x, and then the variable ab, which we have in this case. So this tells me that a cube plus b cube should be equal to 1, and then this is also there, so which means that a cube plus b cube here, it should be equal to 2, sorry. So which means that a is equal to 1, b equal to 1, and then we have 1 cube plus 1 cube, which is equal to 1 plus 1 being equal to 2 in this case. So you realize that we have this to be equal to 2. So therefore we are safe to say that since this is equal to that, which means that the a cube plus b cube here is also equal to s cube minus 3x in this case, right? Now if that is the case, then which means that, because over here to the ab that we add over here, you realize that in this case not here, because if a equal to 1 and b equal to 1, which means that ab, which is 1 times 1 here, right, will be equal to 1 in this case. So basically a is 1, b is 1 in this case. So we are safe to say that a cube plus b cube is basically equal to that, and this is the reason why I made a cube plus b cube the subject, just to make a comparison over here. Now I'll go ahead and further simplify. Now since we have this to be equal to that, let's replace it here, or substitute it there. So we have s cube minus 3x here being equal to, over here, s cube minus 3ab, and then x in this case. So realize that we can then go ahead and then simplify that, right? So in this case, we are going to have two system of equation. Now the first system of equation is basically going to be, we saying that so we had a cube plus b cube. We said that comparing this to that is equal to 2. Let's call this one equation 1 in this case, and then let's go ahead and then um the AB that we also add here, say that AB is also equal to 1 in this case, right? Now if that is the case, then which means that, right, so we can also call this one equation 2. Now this equation here also implies that if we have a squared b squared is also equal to 1. It's the same way when I have a cube multiplied by b cube is also equal to 1. I'm using cube because the first equation also has cube, so let's use that one. Let's call this one equation 3. Now from equation 3 we can write the whole equation, just making one of the variable the subject. So let's make b cube the subject. We have 1 over a cube here, and let's call this one equation, let's say 4 a3. Now we can also make b cube the subject here, right? So from here we can also have b cube being equal to, so we have b cube being equal to just 2 minus a cube, so which means that b cube equals 1 over a3 here. And then we also, from, let's call this one equation 5. From equation 5 we also established that b cube is equal to 2 minus a cube, so we have 2 minus a cube being equal to 1 over a cube in this case. So we realize that we just have one variable, and then we can then go ahead and then safely find what the value of a is. So from here, multiplying all sides by a3, we just have, all right, so you realize that expanding this is basically going to give us, just multiplying each side by a cube, we have 2a cube minus a to the power 6, and then we have being equal to 1, so just writing this becomes a6 minus 2a cube plus 1 being equal to 0. Now we can then go ahead and then say, let's a cube equal to c, another variable, so everything now becomes c cube minus 2c plus 1 equal to 0, and then we can go ahead and then you see that it brings us back to the equation again. But then let's look at something over here. Now remember we said a b equal to 1, and then also a cube plus b cube is equal to 2. Now if that is the case, and remember we also said that we are setting x being equal to a plus b in this case, right? So from these two equations, and then this equation, this assumption that we made over here, then which means that s is equal to, what is a, remember from here, a equal to 1, b equal to 1. So if that is the case, then we have 1 plus 1, s will be equal to 2 in this case. Now this gives us one of the roots of the equation. This tells us s equal to 2, but then there are other possible solutions of s. How do we get that? So we can take this one as a root just by bringing it back. So we have s minus 2 over here. How do we get the other values of s? We can check that using the long division. So using the long division, we can have so let's use long division. So long division is basically the general equation. Remember the general equation here is just s cube minus 3s minus 2, and then we had this to be one of the equations, s minus 2 in this case. Now if that is the case, then we have s minus 2 outside, and then s cube minus 3s minus 2, and then we have to apply the long division rule. So applying the long division rule, now s, we have x to the power 1, s to the power cube. Now s will go into s cube, we have s squared, so s squared multiply these two equations over here, s squared multiply s, we have s cube, s squared multiply minus 2, we have minus 2 s squared. Remember we are subtracting, so this goes to 0. We have minus 3s plus 2, so this is just going to give us remember this is s, so we have nothing to subtract, but then we can just write this back. So you realize that we have negative 3s and positive 2s squared, so we have positive 2s squared, negative 3x, and then we have minus 2 in this case. Now we also have to check again, s goes into remember this part is a non-negative 2s squared, it goes inside positive 2x, so multiply this with that, we have 2s squared here, and then 2s multiplied by minus 2 minus 4x in this case. Subtract again, we have negative s minus 2, and then from here we can see that what goes into that, just positive 1 here, negative 1. So we are going to have positive, not negative. So we have s minus 2 because we have negative s plus 4, which is positive s, and then a minus 2. So we have plus 1. 1 multiplies the whole of that, we have s minus 2, and this goes into that. Now, so which means that the other root of the equation, we have this already, and then we have what the quotient here, 2s plus 1. That's what we have. Now, s squared plus 2s plus 1, we can easily solve this using the quadratic formula. So you realize that we have 1 over here, so basically going to 1 times 1, so we have s squared, then we have plus s, and then plus 1 being equal to 0. Grouping like terms, we just have this to be s plus 1 here, and then we have plus s plus 1. So you realize that we have s plus 1 and then s plus 1, which is equal to 0. So s plus 1 equal to 0, s equal to negative 2, negative 1 in this case, right? So therefore we can then go ahead and conclude that x here is equal to, the first one that we added was positive 2 and negative 1. Now we can then check this answer from the general equation. We can check this answer. Remember, the general equation here is s cubed minus 3s minus 2. If that is the case, then which means that substituting 2, if s equal to 2, here in this case we have 2 cubed minus the 3 times 2. We are going to see whether it will be equal to 2. So we realize that we just have 8 minus 6, which is basically equal to 2. Now if s equal to negative 1, we have negative 1 cubed minus 3 multiplied by negative 1. In this case we have negative 1 then plus 3, which is equal to 2 also in this case. So therefore we can strongly conclude that s equal to 2 and negative 1 in this case. Thank you very much for watching this video. I'll see you guys in the next video.